Alright, so I'll give you two of them. Yep. Find them all. Well, they're two separate problems, part A and part B. Now, if this function only goes from here to here, is there a point when you're finding discontinuities? You look for a jump, you look for a hole, you look for a vertical asymptote. Now, a jump would be like this. There's your jump, where it's a piecewise type of function, where you get one part that goes to here, then it jumps up to here and goes. A hole would be part A. Now, where's the hole? X equals 2. This is the highly technical term of the hole discontinuity. Now, where would you say this one is discontinuous somewhere? Where would you say that what x value will never actually get you a point on the graph? X equals 0. Because when you see a graph like this always means it's going to get incrementally close, infinitesimally close to 0, but never actually achieve 0, or hit x equals 0. They will never touch. So then I get x equals 0 as my discontinuity. Does that make sense? If you know how to do that, you'll be fine. Coolest birthday gift ever? The self-mixing coffee cup. Yeah, but 20 minutes later, when it all settles at the bottom, you just press the little button. It mixes it right back up. Then you get a wonderful cup of joe again. And then it says the force is strong with this one, which makes it even better. My daughter's boyfriend. He's a keeper. Because he's getting me cool stuff. The self-stirring coffee cup. Yeah, you have to wash it by hand all the time, but there's 2 batteries in the bottom. Tangent lines? Alright, so here's a typical type of tangent line equation. What's the equation of the tangent line of f of x equals x squared plus 3x plus 2 at x equals 2? So this is, like I said, your typical tangent line equation. So now I need a point, and I need a slope. So I need a point and a slope. Now I have, the point has to be x comma f of x, and my slope is going to be f prime at x. Those are the two things that we need. So do I have any of these yet? Well, I have x, right? I know we're looking at 2. So I can find f of 2. Yeah, f of 2 would be 4 plus 6 minus 2, which is 8. So I have the point 2, 8. That's what I'm looking at, the graph. Now everybody see where I got the 4 plus 6 minus 2? Alright, so I got my point. Now I need my slope in order to make the tangent line. So how do I figure out the slope of the tangent line? The derivative. So I need f prime of x, which is 2x plus 3. I need f prime at 2 because that's the point we're looking at. 2 times 2 plus 3, which is 4 plus 3, which is 7. So that's my slope. So now I'm going to use y is equal to m times x minus x1 plus y1. Or if we use the whole derivative thing, this is going to be f prime of c times x minus c plus f of x, which is the exact same thing. Because there's your slope, there's your x, there's your y. Same thing. So whatever you're more comfortable with. If you like all this stuff, that's good. If you don't, this is fine. But you have a point, you got a slope, use point slope. So y is equal to my slope, which is 7, x minus my x value, which is 2, plus my y value, which was 8. So simplifying this, and remember, since it's multiple choice, you're going to have to put it in the form that they want. 7 times x, 7x, 7 times negative 2 is negative 14 plus 8. 7x, what, minus 6? There's your tangent line. Make sense? Well, which one? A lot of the limits are straight substitution, because that's pretty much how we do that. Just beware of like the infinite limits. Know when you put an infinity in the denominator that things kind of go crazy a little bit. Niet. Niet. That would be Russian. It says El Gigante from the World Wrestling Federation. He's 8 feet tall. He's huge. Alright, an 8-foot man walks at a rate of 7 feet per second away from a 30-foot lamppost. At what rate is his shadow changing when he is 60 feet away? This one, you're going to draw a picture, because lamppost problems are similar triangles. So they always come down to the same thing. There's the guy, the man, the woman. This guy, it's an 8-foot man. There's your lamppost. Now, where would the shadow be? Is it here or is it here? Alright, so what's the lamppost at? 30 feet. And that's just obnoxiously tall guy. It's Chewbacca. Maybe it's Chewbacca. Who knows? Alright, so do we know the rate of the shadow changing? Alright, so this is 7 feet per second. Okay. And do we know what this value is? Alright, we know this value is x is 60. Do we know what this whole thing is? If we do this and say, alright, we know at that point, we'll say that this whole distance is y, right? And this is going to be y minus 60, isn't it? So that's what we're going to end up using. So there are two. Now, we don't use this right off the bat because it's an instant distance. We'll just plug it in for x at the end. Remember, we plug in our values when we have them. So we got this triangle where we got y minus 60 over 8, and then we have the big triangle absolutely. Yeah, 8y minus 480. Move that over. Get 22y is equal to Yep. Now it's just becoming an obnoxiously large number. Because you're going to subtract 30 from both sides. You could have. Yeah, it's 60 times 30. That's our length of the shadow. You know what I did wrong? Anybody know what I did wrong? Of course I did. I always do something wrong. I used the 60. Did someone just say that we should have... I didn't hear you. There's a difference between listening and hearing. I don't do either well. Just do this. X and Y. Just like that. We know that's 8. We know that's 30, right? We know dx dt. Sorry, I just biffed this one. It's been a while. Related rates is one of those skills that if you don't use them, it just kind of erodes on you. Dx dt is, we know that's 7 feet per second, and we want dy dt, right? All right, so if I take the small one, y over y plus x, that's equal to the small one, which is 8, right? Y plus x to get the total distance. Because I have to do the small triangle and the big triangle. And so that's 8 over 30. Better? All right, distribute. Sorry about that. Distribute. So you get 30y is equal to 8y plus 8x. Hold on a second. Mr. Fordari. Hey, what's up? Okay. All right. No problem. Bye. All right. So 22y is equal to 8x. Take the derivative of both sides. So it'll be 22 times dy dt is equal to 8 times dx dt. So I want dy dt, so I want this to be dy dt.
Dan, please excuse the interruption. Can students please be aware that the elevator is not working at this time? Any students or staff needing to go from the first or the second floor, you need to use the ramp at this time. Also, Ms. Mariano's fourth-hour class, the pizza party has been canceled. You need to eat your lunch in the cafeteria during your lunch today. Thank you.
All right, remember dx dt is 7 feet per second, and I had the 8 and the 22 divided by 22, got the 8 over 22, 7 feet per second. What for? I reduced.